Welcome to the Clinical Podcast Series brought to you by the American Academy of Optometry Foundation. The topic for today's episode is visual acuity outcomes in a randomized trial of Wavefront metric optimized refractions in adults with Down syndrome. I'd like to thank our host, Dr. April Jasper, our topical expert, Dr. Heather Anderson, and our topical editor, Dr. Plaumann. And now, over to April.
Hi, everyone. I'm April Jasper, and I'm speaking today with Heather Anderson, an associate professor at The Ohio State University College of Optometry. Heather completed both her OD and PhD training at the University of Houston and is a fellow of the American Academy of Optometry. Today, she will be discussing the January 2022 Optometry and Vision Science paper entitled Visual Acuity Outcomes in a Randomized Trial of Wavefront Metric Optimized Refractions in Adults with Down Syndrome. This is really special, though, because this paper is actually authored by Heather and her collaborators from work conducted at the University of Houston College of Optometry. Heather, thank you so much for sharing your work with us. I think probably you should tell everybody a little bit more about yourself because they may not have listened to our other broadcasts together. So let's do that first.
Sure. So as you said, I'm an associate professor at the Ohio State University College of Optometry. I also chair the graduate program in vision research here. I moved up to Ohio at the end of 2019, and prior to that, I had been faculty at University of Houston where this work was done. And my research is typically with pediatric populations, but I also work with special populations, and this particular work is with adults with Down syndrome.
So let's dive right in. Heather, can you share a little bit about the motivation for this work and what question you were trying to answer?
Sure, I'd be happy to. So patients with Down syndrome typically have reduced visual acuity. And even when we get a refraction in place, we're usually not correcting them to 20/20. In fact, their visions can sometimes range in the visual impairment range with 20/50 or worse acuity. And the source of this reduced acuity is somewhat of a mystery, but we are hopeful that some of it is due to optical deficits. And so maybe corneal distortions, they have very high refractive errors, often large magnitudes of astigmatism, and they can be very challenging to refract because a lot of times we're left to rely on our doctor assessment with retinoscopy and autorefraction and some of our more objective tools, then we can rely on subjective refraction. Another thing that is unique with this population is that they have elevated higher order aberrations. When we think of higher order aberrations, we automatically think of patients with keratoconus who have significant corneal distortions. And typically this group isn't to that level, but they are elevated compared to the general population. And so the best prescription for an eye with elevated higher order aberrations isn't always intuitive, and it might not be the full retinoscopy that we scope. There might be a need to cut the still or shift the axis or give a different sphere power to compensate or balance out some of those higher order aberrations. Yeah. And so with this work, what we're trying to do is see if we can provide better prescriptions for these patients if we take a wavefront measurement first and then let computer analysis predict what the best prescription is going to be.
Wow, that sounds like an interesting approach, quite amazing, and certainly providing more tools to clinicians to care for special populations would be very valuable. So tell us a little bit about the study and how you tested this new prescribing strategy.
Sure. So for this study, we enrolled 30 adults with Down syndrome, and these folks had a wide range of refractive errors. And they came in and had a comprehensive eye examination performed by one of the investigators that was part of the study team who has extensive experience working with special populations. And this examiner was not privy to any of the information about the wavefront aberrations and that type of prescribing strategy that we were testing. She was just using her regular techniques that she would use in a clinical exam. And she figured out what she thought the best prescription would be for these patients, and she could use pre-dilation and post-dilation methods. And that was one of the pairs of glasses that we tried. But then we also took wavefront aberration measurements and through computer analysis came up with 2 alternatives that we wanted to try. And we let our patients pick out glasses from the optical, and we ordered 3 identical pairs and made all 3 prescriptions. And we shuffled them up and we sent each one out the door for 2 months at a time to see how visual acuity did with each pair of glasses. And we were able to use a pretty rigorous visual acuity test for these patients. So they were doing a Bailey-Levy style test, reading from the top of the chart down until they were making mistakes. And we wanted to see, could we do at least as good as the clinician, or could we even beat the clinician with these computerized methods?
Well, I can tell that you are eager to give us the results. I certainly want to hear them. So what was the result of the study? Did the wavefront-based refractions do as well as you predicted?
So overall, all the participants benefited from being in the study because our group as a whole, if we take their acuities and average them together, the group as a whole did align better with each of the treatments that were dispensed. But it was really a tie between the clinician and the wavefront optimized corrections. And some might think, well, then you didn't beat the clinician. But we still thought it was a big win because our clinician was somebody that we consider to be really top for working with this population. And so if we can then take a wavefront measurement and do computer analysis and do as well as that clinician, we see that as a big win and a tool that's worth continuing to explore for patients to be able to have access to in the future.
It sounds really encouraging to me. I think I agree with you. It does sound like a win, but what are the next steps? So what's coming next, and how will we be able to use this going forward?
So the next steps for this study, particularly for our research group, is that we're going to test this treatment strategy in children with Down syndrome. We included adults in the first group, and some of those adults were in their 40s and 50s. And we believe that if you've experienced poor visual quality your entire life, it's going to be hard to budge your acuity once you're in your 40s or 50s if there's some long-standing bilateral amblyopia present. And so our next goal is to get these treatments onto children with Down syndrome who are maybe in a more plastic phase neurally and could potentially get better visual acuity outcomes from the treatments.
Well, I will tell you that sounds exciting. It sounds amazing, wonderfully valuable to patients. And my words always are, hurry it up.
Thank you.
So Heather, thank you so much. I love that this was actually your work, of course, your collaborators as well, but it's even more special that we have the opportunity to have you tell us about something you were that heavily involved in. So thank you so much for being here with us today.
You're welcome.
And a special thanks to CooperVision for their educational grant to make it all happen.